Good evening, friends. Welcome to your own YouTube channel, Unacademy GATE ESE PI. This is your educator Aprup Rao, and you are watching the lecture series of machine design. Now, beta, hit the like button and share the link with with your friends. Share the link of this video with all your friends. Share the link. Share the link. Share the link. Welcome, 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 welcome. Now, beta, those of you who are watching me for the first time, let me introduce myself. My name is Aprup Rao. All India rank 320 in GATE Mechanical. I have done my MTech from IIT Kharagpur. I have 2+ years of working experience in Mahindra Research Valley, which is the R&D center of Mahindra and Mahindra Automobile. Then I quit my job and I started teaching. So I've been teaching for more than 6 years now. And I teach subjects related to design, strength of material, machine design, engineering mechanics, and theory of machines. And I have been teaching all these subjects here on YouTube and on Unacademy Plus. And if you are following my lectures, then beta, I can surely say that your concepts of design will be crystal clear. Good evening, Aniket. Good evening, Mahadev Prasad. Good evening. Good evening. Good evening. Welcome, 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 beta. Share this link with your friends. Let them know that we are live. Let them know that we are live. There was a technical glitch, but now we are live and it is working perfectly fine. Of engineering mechanics, a digital book of engineering mechanics, where lecture by lecture I have uploaded the YouTube classes and the PDF links of all the 38 lectures that I have taken on engineering mechanics. It is a complete syllabus of engineering mechanics. You will find every lecture, every topic, every lecture in this Excel sheet. So just go to tinyurl.com/approve10 and open this Excel sheet and enjoy these classes. And along with this, we also have a digital book of machine design, which is an ongoing course now. We have completed 5-6 lectures till now. So beta, you will find the YouTube class link and the PDF link of all those classes that we have taken till today. After every lecture, beta, within 1 or 2 hours, I update this Excel sheet. So if you want to download the PDF of this class also, it will be available after 1 or 2 hours after the lecture ends in this Excel sheet. And where you will find this Excel sheet? tinyurl.com/approve10. So go to this website and enjoy the ebooks and enjoy the YouTube classes. And a very important information for you, from the month of October, the subscription fee of Unacademy Plus for GATE and ESE category is going to hike. So beta, if you are planning of taking Unacademy Plus subscription, this is the time. Take the subscription within these 2-3 days so that you will be in benefit. Otherwise, if you be late, then you will have to pay a lot more than what you have to pay now. So beta, make your judgment and take the Unacademy Plus subscription. What you are going to get? You are going to get live classes completely in English as well as in Hindi. You are going to get additional doubt clearing sessions. You are going to get weekly tests. You are going to get crash courses for different exams. Apart from GATE and ESE, there are other exams also, PSU exams. So you will get crash courses for all those exams, and you will get rank improvement batches. You will get rank booster batches. So beta, these are the additional benefits of Unacademy Plus. So if you want to take the subscription, join now. Don't be late. A lot of students are joining because of this price hike. So be among them and take the subscription right now using the code APPROVE10. Take the subscription right now using the code APPROVE10. Now beta, today's class is on design against static loading, and today we are going to cover a very important topic which is known as theories of failure. So this topic, this chapter, this session is very, very important from every exam's point of view, and it is also important for the basics of machine design. So beta, don't miss this lecture. Be with me till the end. Share the link with your friends also. Let them know that we are live. Let them know that we are online. Good evening, Sameer. Good evening, Naveen. Good evening, Shubham. Good evening, Dhananjay. Welcome, everyone. So beta, today we are going to start theories of failure. I am going to explain the concept of theories of failure like you have never understood before. I am going to explain everything you need to know about theories of failure, and it is very important from exam point of view. You might get theory questions from this topic, you might get numericals from this topic, and it is important for every exam, be it GATE, be it ESE, be it any PSU exam. Theories of failure is a very important topic. Okay, it is also important for XC students. If you are thinking of giving the GATE exam from XC paper, then also theories of failure is important to you. Okay, now beta, in order to understand design against load, we need to first understand what are the different types of load. So from design point of view, we can divide the loads into two categories. Although there are several types of loads, there are different types of classification based on the nature of load and all. But beta, from machine design point of view, we can divide the load into two categories: static load and fluctuating load. Let's understand the difference between static and fluctuating load. So in case of static load, the load remains constant with respect to time. स्टैटिक लोड का मतलब है लोड जो है वो टाइम के साथ चेंज नहीं हो रहा है. द लोड इज कांस्टेंट विथ रिस्पेक्ट टू टाइम. द मैग्नीट्यूड एज वेल एज द डायरेक्शन इज कांस्टेंट विथ रिस्पेक्ट टू टाइम. सो इफ आई ड्रॉ अ ग्राफ बिटवीन स्ट्रेस वर्सेस टाइम, if I draw a graph between stress versus time, then I am going to get a horizontal line, because the stress will always be constant with respect to time. It is not going to change. But in case of fluctuating load, if I draw a graph between stress and time, then you will see that the stress is going to fluctuate between a maximum and a minimum value. Let's call it sigma minimum. Let's call it sigma maximum. So you can see that the stress is not constant. It is fluctuating from sigma minimum to maximum, then maximum. So this is known as fluctuating load. This is known as static load. In case of static load, sigma maximum and sigma minimum both are equal. The stress is constant. What will be the practical example? The weight of yourself on the desk or bench or whatever chair you are sitting on is a static load. Your weight acting on the chair is a static load. Your weight is not changing with respect to time, right? But beta, consider the piston cylinder of an IC engine. So the piston is continuously moving, okay, and the load applied by the piston on any component connected to the piston is continuously changing. So beta, that load will be a fluctuating load. The load coming on the suspension of a vehicle is also fluctuating load. The load coming on the suspension, because the vehicle is moving on a road, so it sometimes goes from a speed breaker, it sometimes goes from a pothole. So the load is continuously changing. So these are some of the examples of fluctuating load where the load is not constant. It is continuously fluctuating. So beta, we can divide the load into these two categories. Now the design process in static load and in fluctuating load is completely different. That's why we see two different chapters, design against static load and design against fluctuating load. दोनों के केस में जो डिजाइन इक्वेशंस हैं, जो डिजाइन प्रोसेस है वो completely different है. We will understand the difference why. Okay, why the design process is different in static load, why it is different in fluctuating load, that we will see later. Okay, so beta, right now we are starting design against static load. In this chapter we are only going to deal with static load. After that we will deal with design against fluctuating load. Okay, now when I say design against static load, what does it mean? जब मैं आपको बोलता हूं कि मुझे लोड के अगेंस्ट डिजाइन करना है, तो इसका मतलब क्या है? What do I mean by design against static load? Let's understand this. Okay, so let's say we have a cylindrical body. एक सेकेंड, हाथ से ही ड्रॉ कर लेते हैं. Let's say we have a cylindrical body. Okay, let's say we have a bar which is subjected to axial load. It is subjected to an axial load of, let's say, 10 kilonewton. Okay, and I want you to calculate the diameter of this bar. Okay, so beta, what you are going to do is you are going to find a suitable diameter of this bar so that it can sustain 10 kilonewton load without failure. So that is known as design against static load. Design against load बोलने का मतलब क्या है? What do I mean by design against load? That I am giving you a loading condition. I am giving you the value of load and I want you to find a suitable dimension of the body so that it can sustain that load without failure. I want you to find a suitable value of this diameter so that this bar can sustain 10 kilonewton load without failure. This means design against static load. Now there can be different types of load. There can be different types of members. For example, if I talk about a shaft, the shaft is subjected to bending as well as twisting. So if I give you a bending moment and a twisting moment, this shaft is subjected to this much bending moment, this much twisting moment. Find the diameter of shaft. So that is design of shaft against the static load. For example, let's say I give you pressure vessel. Let's say I give you thin cylinder. That this thin cylinder is subjected to this much pressure. Find the thickness of this cylinder. How much thickness do we need in order to sustain this pressure? So that is design against static load. So do you understand the meaning of design against load? आपको clear हो रहा है कि design against load बोलने का मतलब क्या है? Yes, yes, very good guys, very good. Now beta, how do you design against load? What do you need in order to find a suitable diameter of this bar? See, in order to find a safe diameter of this bar, first I need to know how this bar can fail due to this load of 10 kilonewton. अगर आप इसका डायामीटर कैलकुलेट करना चाहते हैं, एक सुटेबल डायामीटर कैलकुलेट करना चाहते हो, तो आपको पहले ये पता होना चाहिए कि ये बार कितने कितने तरीके से फेल हो सकता है, ये बार कैसे फेल होने वाला है, राइट? In order to save this from failure, we need to know how it can fail. You want to save this bar from failure, right? So in order to do that, first you need to know how this bar can fail, right? So beta, under static load, material may fail. Under static load, material may fail due to, first, yielding, which is also known as plastic deformation, or fracture, right? These are the two types of failure you might get due to static load, right? The material might yield or the material might fracture. Now we have seen the concept of yielding and fracture in strength of materials. Strength of material में आपने पढ़ा होगा yielding क्या होती है, fracture क्या होता है, right? What is yielding? Yielding means the start of large plastic deformation. When the body starts deform plastically, then we say that the body starts yielding. Now why this is a failure? If the body starts deforming plastically, why do we assume that the material has failed? अगर body में plastic deformation हो रहा है, तो हम क्यों मानते हैं कि material fail हो गया है? Understand, plastic deformation means permanent deformation. Okay, if you remove the load, the material is not going to regain its shape and size. That is the plastic deformation or permanent deformation. So understand why this is a failure. When a ductile material is subjected to load, first it deforms elastically, and elastic deformations are very small. So the shape and size of the body changes, but it changes negligibly. So it does not hinder the function of the member. यानी कि मेंबर के फंक्शन पे उसका बहुत ज्यादा असर नहीं पड़ता है. द मेंबर कैन फंक्शन प्रॉपरली विद इन इलास्टिक डिफॉर्मेशन, बट व्हेन द मटेरियल स्टार्ट्स डिफॉर्म प्लास्टिकली, plastic deformations are permanent deformations and they are large. So the shape and size changes drastically, due to which the body is not able to perform satisfactorily. The body cannot function properly. So that's why we assume that the body has failed. So if you have a machine member made of ductile material, when it will start yielding, I will assume that the member has failed. अगर आप डक्टाइल मटेरियल का कोई मेंबर डिजाइन कर रहे हो तो अगर वो यील्ड हो जाता है तो मैं मान लूंगा कि वो फेल हो गया. Why? Because if it starts yielding, the shape and size will drastically change and it will not be able to function properly. It will not be able to do its work properly. That's why I will assume that it has failed. And in case of brittle material, if the material fractures, if the material breaks, then I will assume that the material has failed. Because in brittle material there is no yielding. Yielding only occurs in ductile material. In brittle material there is no yielding. So beta, if the brittle material fractures, then I will assume that the material has failed. Now beta, we know the stress at which the material is going to yield and the material is going to fracture. हमें हर मटेरियल का वो स्ट्रेस पता है. We know that at this stress, this material is going to yield, this material is going to fracture. Okay, how do we find that stress? We find that stress using simple tension test. Using simple tension test. For finding the strength of material. Strength of material बोलने का मतलब क्या है? Strength of material means how much stress I can apply without yielding and without fracture. Okay, so let's say you need to find the strength of a material, let's say steel. Then what do? You make a specimen of that material. आप उस मटेरियल का एक स्पेसिमेन बनाते हो, कुछ इस तरीके का एक स्पेसिमेन होता है, ठीक है. Then you put this specimen in universal testing machine, right? This is the specimen. ये अपना specimen है, standard size and shape का specimen होता है. Then we put this specimen in universal testing machine and we apply tensile load. We apply tensile load. Okay, we apply a tensile load like this. Okay, then we see the stress and strain at different points and we plot a graph which is known as stress strain graph, right? This is stress, this is strain. So I am going to plot a graph like this. Okay, this is a graph of a ductile material. Okay, so the point at which the material yields, stress at that point is known as yield strength, SYT, and the point before the material fractures, maximum stress before the material fractures, is termed as SUT. This you have studied in strength of material. ये आपने strength of material में पढ़ा होगा, है ना? ये आपने strength of material में already cover किया हुआ है. So बेटा, this is the point where the material yields and this is the point where the material fractures. So before that, maximum stress is here. So beta, this is the yield strength, this is the ultimate strength. Okay, so material will yield if the stress is more than SYT and the material will fracture if the stress is more than SUT. मैं यहाँ लिख देता हूँ, if stress is more than SYT, the material is going to yield, and if the stress is more than SUT, the material is going to fracture. Okay, so beta, in order to find the stress at which the material is going to yield and fracture, we are going to perform simple tension test. We are going to draw this curve, we are going to draw this diagram, and we are going to find SYT and SUT. Okay, so now we have SYT and SUT. So beta, now the objective is to find a suitable diameter. अपने को एक suitable diameter चाहिए. Okay, so how do we find this suitable diameter? Understand beta, understand. Okay, again Our objective is same. We need to find a suitable diameter for this body. Okay. This is our body. This is our bar, cylindrical bar. Okay. Subjected to an axial load of 10 kilonewton. P equal to 10 kilonewton. We need to find the diameter of this bar. Let's say this bar is made of a ductile material and I have the value of SYT 300 megapascal. Okay. Now, we need to save this material from failure. Right. Now, it is a ductile material. So, how it is going to fail? ये कैसे fail होगा? By yielding. फ्रैक्चर तो बाद में आएगा, पहले यील्डिंग आएगा. तो अगर यील्डिंग से बचा लिया मतलब फ्रैक्चर से बचा लिया, राइट? सो बेटा, इन ऑर्डर टू सेव दिस फ्रॉम यील्डिंग, व्हाट विल बी द इक्वेशन टू सेव from yielding? What will be the equation? Due to this load, there will be sigma x, right? That sigma must be less than SYT. This is the equation, right? If this sigma becomes equal to or greater than SYT, the material is going to fail. So beta, in order to save this, sigma should be less than SYT, right? Sigma जो है वो SYT से कम होना चाहिए, because if my sigma is less than SYT, it is not going to fail. It is not going to fail. It is not going to yield. Now, if I only say that sigma should be less than SYT, can you calculate the diameter? No. Beta, if I say sigma should be less than SYT, it doesn't mean anything. I need to specify less means how much less. Whether it should be 1/3, whether it should be 1/4, whether it should be 1/5. How much less? Because if SYT is 300, then 299 megapascal is also less than 300. So can you put sigma equal to 299? No. I can't put sigma very close to SYT. Why? Because my design is not very accurate. So I can't put sigma very close to SYT. I need some factor of safety. I need to be safe. So beta, what I will use? I will use a factor of safety. I will use a factor of safety. मैं एक factor of safety use करूंगा. What is factor of safety? Beta, see, your sigma should be less than SYT. Okay, you can't keep your sigma very close to SYT. Why? Let's say SYT is 300 and your sigma is 299. You are thinking that it is less than SYT, so I am safe. But beta, whatever procedure you have used, that is not very accurate. And the loading conditions are also not constant forever. They change. So beta, if anything changes and accidentally your sigma becomes greater than, your sigma increases by 1 megapascal or 2 megapascal, then the body is going to fail. So you can't keep your sigma very close to SYT. It should be less than SYT. Less than matlab, if SYT is 300, it can be maximum 250, 200, 150, 100, like that. You can't keep it 299, 298. No, very close means that it is a dangerous game. If your sigma increases slightly, the body is going to fail. So you need to be safe. So that's why you use factor of safety. Now understand, this is the relation between stress and strength. ये क्या है? This is the relation between stress and strength. What is stress? This sigma is the stress. What is strength? This SYT is the strength. So this relation is a very important relation because you are going to get your dimension from this relation only. So in this relation, if I put sigma equal to P by A, your sigma will be equal to what? P by area. So if I put sigma equal to P by A, what I am going to get, beta? If I put sigma equal to P by A, I will get 10 kilonewton divided by pi by 4 d square SYT is 300 megapascal, and let's say factor of safety for example is 2. So from here I can find the diameter. मेरे को diameter मिल जाएगा. I will find the diameter. I will find the value of diameter required to save this from yielding, right? To save this bar from yielding. So do you understand the design process against static load? आपको static load में design process clear है? Do you understand the design process against static load? Do you understand the design process against static load? Yes, yes. So beta, now this is the process that we follow in order to design under static load. So in order to design any body under static load, what do you need? You need a relation between stress and strength. Stress means if you apply the load, what stress is coming on the body. Strength means what is the strength of the material of the body. Now beta, understand. In this case, the loading was very simple. इस केस में लोडिंग बहुत सिंपल थी. There was only one axial load acting on the body. We were getting only one sigma. So this relation was very easy. Sigma equal to SYT by FOS. But let's say I have a circular bar subjected to an axial load as well as a twisting moment. मान लो सर्कुलर बार पे एक एक्सियल लोड भी लग रहा है और एक ट्विस्टिंग मोमेंट भी लग रहा है. सो नाउ बेटा देयर विल बी टू स्ट्रेसेस. सिग्मा इक्वल टू P upon pi by 4 d square and tau equal to 16 t by pi d cube. There will be an axial stress, there will be a torsional stress, right? Now, what will be the relation between stress and strength? In this case, there was only one sigma. So we had a relation, direct relation between stress and strength. But here we have two stresses, one sigma and one tau. So what will be the relation of this sigma and this tau with SYT? That is the problem. Do you understand the problem in this case? आपको प्रॉब्लम क्लियर हो रहा है. यहां पे प्रॉब्लम क्या आ रही है? इससे पहले वाले केस में सिर्फ एक सिग्मा था. देयर वाज ओनली वन लोड, वन सिग्मा. सो देयर वाज अ डायरेक्ट रिलेशन बिटवीन सिग्मा एंड SYT. बट इन दिस क्वेश्चन we have one sigma and one tau. Both are acting simultaneously on the body. So in this case, how I am going to find a relation between this sigma, tau and SYT? There must be a relation. Without that relation, I cannot calculate the suitable diameter. मैं एक suitable diameter नहीं निकाल सकता. I can't find the suitable diameter by relating only this sigma with SYT. No. Why? Because this tau is also there. This is also going to contribute towards the failure. Failure में इसका भी हाथ होगा, तो मैं इसको ignore नहीं कर सकता. I have to find a relation of SYT with both of this, sigma and tau. Both of them should be in that relation. So beta, how I am going to find that relation? How I am going to find a relation between sigma, tau and SYT? So beta, under these type of loading conditions, we need certain theories in order to find relation between stresses and strains. Sorry, stresses and strength. Stress or strength means sigma and SYT. When you have this relation, you can find the dimension of the body. Without this relation, you can't find the dimension. So in order to have that relation, we need certain theories, because here we have a sigma and a tau. So how this will be related to SYT? For that we need certain theories. Those theories are known as theories of failure. Do you understand what do I mean by theories of failure? आपको क्लियर है? अगर मैं बोल रहा हूं theories of failure, तो इसका मतलब क्या है? Theories of failure means these are the theories which are going to give us relation between stresses and strength of material under biaxial or triaxial loading. Biaxial और triaxial loading का मतलब क्या है बेटा? What do I mean by biaxial loading? What do I mean by biaxial loading? Biaxial loading means biaxial loading बोलने का मतलब क्या होगा? One sec. Biaxial loading means, let's say we have stress in x direction as well as in y direction. This is known as biaxial loading, right? Sigma x, sigma y and tau xy. ठीक है? You might have studied this in strength of material. Strength of material में ये हम लोग पढ़ चुके हैं बेटा. If you don't know this, then you need to go and watch my lectures of complex stress. Otherwise you will not understand this. Okay? तो बेटा complex stresses पढ़ लो अगर आपको ये चीज समझनी है तो. Okay? So बेटा there is sigma x, there is sigma y and there is tau xy. So this is known as biaxial loading. Okay? And what do I mean by tri-axial loading? Tri-axial loading बोलने का मतलब क्या है? What do I mean by tri-axial loading? If I say tri-axial loading, that means there will be stresses in all three directions. Biaxial में there will be stresses in only two directions, x and y. In case of tri-axial loading, there will be stresses in all three directions. ठीक है? So you will get stresses like this beta, sigma x, sigma y, sigma z. You will get tau xy, tau xy, tau yx, tau xz and tau zx. Okay, अभी उसको fill करूंगा तो time लगेगा. So let me leave it like that. Okay. So beta, this is tri-axial loading where we have sigma x, sigma y, sigma z, tau xy, tau xz, tau yz. Okay, here we only have sigma x, sigma y and tau xy. Only stresses in x and y direction. Here we will have stresses in x, y and z direction. Let me fill it all. तो आप लोगों को clear हो जाएगा. This is tau xy, this is tau xz, this is tau yx, this is tau yz, this is tau zx and this is tau zy. Okay. So there are 9 stresses here and there are 4 stresses here. Okay, so this is biaxial loading, triaxial loading. Okay, so beta under these loading we have multiple sigma and multiple tau. This is uniaxial loading. ये क्या है बेटा? Uniaxial loading. Uniaxial loading में we have no issue. Uniaxial loading में कोई issue नहीं है. Why? Because in uniaxial loading we only have one sigma. So I can relate this sigma directly with SYT or SUT. But in case of biaxial or triaxial loading, we have multiple sigma and multiple tau. For example, this is biaxial loading. We have one sigma and one tau. This is biaxial loading. So in this case, we need to find relation between stresses and strength using theories of failure. आपको stress और strength के बीच में relation चाहिए तो उसके लिए आपको क्या चाहिए होगा? Theories of failure. So beta, let's understand what do we mean by theories of failure. By now, I think everyone is clear about what is the requirement here, what is the problem here. यहाँ problem क्या हो रही है, क्या requirement है, आपको यहाँ तक clear हो गया होगा. यस, सौविक, नवीन, राजू, उमेश, अनिकेत, नीरज, यस, कोमल, नासिर, निर्मला, यस, यस, okay, okay, okay. So beta, by now, everyone is clear about why do we need theories of failure, right? अपने को problem क्या हो रही है, that is clear. So let's understand what is theories of failure and how it is going to solve our problem. Okay, theories of failure are used to relate stresses with strength of material under biaxial or triaxial stress condition. Theories of failure क्या देंगी हमको, ये हमको क्या देने वाले हैं, what is our objective from theories of failure? They are going to give us relation between strength of material with stresses. Relation between strength of material with stresses under biaxial and triaxial loading condition. Biaxial or triaxial loading condition means multiple sigma, multiple tau. We have more than one sigma, more than one tau. In that case, we need a relation between multiple sigma tau and SYT and SUT. Stresses, strength. Without this relation, we can't find the diameter. I have already shown you how to find the diameter, right? Now these are theories which predict how the machine element will fail under biaxial or triaxial loading. Theories of failure, failure का मतलब समझो. Theories of failure means these theories are going to tell us how that machine element is going to fail under biaxial or triaxial loading. So what we do is we make some assumption. हम एक assumption लेते हैं और उस assumption से हमको एक relation मिलता है. Okay? For example, let's say I have this biaxial loading. Okay? Let's say I have this biaxial loading. Now beta, let's assume that under this loading, the machine element is going to fail if your sigma maximum becomes equal to SYT. मान लो मैंने एक assumption ले लिया. Let's make an assumption that if this loading condition is there, if sigma x, sigma y and tau xy all are acting, then your machine element is going to fail if your sigma maximum will become equal to SYT. So beta, that prediction, that theory is going to give you a relation between sigma x, sigma y, tau xy and SYT. Let's say some theory assumes that your machine element is going to fail due to tau maximum. So beta, again you will get some relation between sigma x, sigma y, tau xy and SYT. Another theory will say that your machine element is going to fail due to strain energy. So beta, there are different theories which are going to tell us that due to this particular parameter, your machine element is going to fail, and based on that assumption, I am going to derive a relation between stresses and strength of material. So beta, now we have to see what are those different theories of failure. In each theory, what is that assumption, and based on that assumption, what relation are we getting? हर theory of failure से हमको एक relation derive करना है. From every theory of failure, we need to derive a relation between stresses and strength of material. So let's see one by one what are those different theories of failure and what relation are we going to get. एक एक करके देखेंगे कि सारी theories of failure क्या हैं और उनसे अपने को क्या relation मिल रहा है. So beta, in our syllabus we have 5 theories of failure: maximum normal stress theory, maximum shear stress theory, maximum strain energy theory, maximum distortion or shear strain energy theory, and maximum normal strain theory. I am going to derive the relation between stress and strength using all these 5 theories of failure. We are going to understand each and every theory of failure. We are going to find those relations. So let's start with the first theory of failure, that is maximum normal stress theory. Let's understand the statement of maximum normal stress theory and then we will derive the relation. Now यहाँ पे एक चीज बहुत important है. Here there is one very important thing that I need you to understand, that with every theory I will tell you the name of the person who gave this theory, and this name is very important. For example, maximum normal stress theory is also known as Rankines theory. Now this is very important, that's why I have highlighted this. Why it is very important? Because first of all, they can ask you this in theory. Okay, maximum normal stress theory was given by whom? Okay, and second, in numericals also they might mention the theory of failure by this name, Rankines theory. Let's say they are giving you a question to solve and they are saying that use Rankines theory of failure. So if you don't know which one is Rankines theory, then you will not be able to solve the problem, right? So with every theory of failure, you need to remember this name also. So maximum normal stress theory is known as Rankines theory. Let's understand the statement first. A machine element subjected to biaxial or triaxial stress fails when the maximum normal stress at a point in the machine element reaches the value of maximum normal stress in a standard specimen of the simple tension test during failure. In other words, your machine element is going to fail if your sigma maximum becomes equal to sigma maximum of the specimen during simple tension test. Simple tension केस के टाइम पे जो सिग्मा मैक्स निकलता है, अगर स्पेसिम आपके मशीन एलिमेंट का सिग्मा मैक्स उतना हो गया तो आपका मशीन एलिमेंट फेल हो जाएगा. सो डू यू अंडरस्टैंड द प्रिडिक्शन हियर? यहां फेलियर को कैसे प्रिडिक्ट किया जा रहा है? हाउ वी आर प्रिडिक्टिंग द फेलियर? वी आर अज्यूमिंग दैट द मटेरियल इज फेलिंग ड्यू टू सिग्मा मैक्स. हमारा ये अजम्पशन है कि मटेरियल जो है वो सिग्मा मैक्स की वजह से फेल हो रहा है. सो बेटा व्हाट इक्वेशन आर वी गोइंग टू गेट? लेट्स अंडरस्टैंड दैट. ओके, सो अकॉर्डिंग टू दिस थ्योरी, the machine element is going to fail when the sigma max of machine element will become equal to sigma max of specimen. तो बेटा first we need to find what is sigma max of specimen. तो सबसे पहले तो specimen को देख लेते हैं. Let's first see the specimen. Okay. So बेटा this is the specimen. ये अपना specimen होता है. हॉरिजॉन्टल ड्रॉ कर रहा हूं इन ऑर्डर टू सेव द स्पेस. ओके, आई एम ड्रॉइंग इट हॉरिजॉन्टली इन ऑर्डर टू सेव द स्पेस. ओके, इट इज सब्जेक्टेड टू यूनिएक्सियल टेस्ट, यूनिएक्सियल लोड, राइट? इन सिंपल टेंशन टेस्ट दिस इज द लोड. नाउ बेटा व्हाट दे आर सेइंग? मैक्सिमम नॉर्मल स्ट्रेस ऑफ सिंपल टेंशन टेस्ट ड्यूरिंग फेलियर. ड्यूरिंग फेलियर व्हाट इज मैक्सिमम नॉर्मल स्ट्रेस हियर? तो यहां पे फेलियर के टाइम में मैक्सिमम स्ट्रेस कितना रहता है? If it is a ductile material, then maximum normal stress will be SYT, and if it is a brittle material, then maximum normal stress will be SUT. This is clear to everyone. If this specimen fails due to yielding, then the maximum normal stress will be SYT, and if it fails due to fracture, then maximum normal stress will be SUT. So for this specimen, sigma max is either SYT और SUT, राइट? इस स्पेसिमेन के लिए सिग्मा मैक्स क्या है? SYT है या SUT है, राइट? नाउ द मशीन एलिमेंट. नाउ आवर मशीन एलिमेंट इज सब्जेक्टेड टू बायएक्सियल और ट्राईएक्सियल लोड. ठीक है, अपना जो मशीन एलिमेंट है उस पे बायएक्सियल या ट्राईएक्सियल लोड लग रहा है. ओके, सो नाउ बेटा, in order to find sigma max of this machine element, what we are going to do? We are going to find the principal stresses. We are going to find the principal stresses. Beta, I have explained the concept of principal stresses already. So if you don't know the concept of principal stress, please watch my videos of strength of material. Okay, complex stress strain का knowledge होना इस chapter के लिए बहुत जरूरी है. In order to understand this chapter, you need to understand the concept of complex stress. If you don't understand that chapter, then you will not be able to understand this chapter. Okay, so beta, those of you who don't know anything about principal stress, anything about complex stress, I will suggest you watch my lecture of complex stress. After this lecture, you go to my playlist of SOM and watch the lecture of complex stress. Okay, now understand, let's say the principal stresses, are sigma 1, sigma 2 and sigma 3. ओके, मान लो अपने जो प्रिंसिपल स्ट्रेसेस हैं वो सिग्मा 1, सिग्मा 2 एंड सिग्मा 3 हैं. आई थिंक प्रिंसिपल स्ट्रेस का principal stress, I think this is the spelling, I don't remember the spelling. So principal stress is sigma 1, sigma 2, sigma 3, let's say. So what will be sigma maximum here? Sigma maximum will be maximum of sigma 1, sigma 2 and sigma 3, right? What will be sigma max? Sigma max क्या होगा? Sigma max होगा इन तीनों में से जो भी सबसे बड़ा होगा. Okay, right now I don't know which one is maximum. Okay, right now I don't know whether sigma 1 is maximum or 2 is maximum or 3 is maximum. I don't know that. Okay, So beta, I have the sigma max of specimen, I have the sigma max of machine element. Okay, now according to this, the machine element is going to fail when sigma maximum of machine element will become equal to sigma max of specimen. So in order to avoid failure, the sigma maximum of machine element, whatever machine element you are designing, should be less than sigma maximum of the specimen, right? Sigma maximum of the machine element should be less than sigma maximum of the specimen. Now what is sigma maximum of machine element? That I don't know exactly, because right now I don't know whether it will be sigma 1 or sigma 2 or sigma 3. So I will write it simply sigma max. ठीक है, अभी मेरे को पता नहीं है कि कौन सा बड़ा है, so I will write it simply sigma max. Okay, whichever is greater, you put that value here. Okay, so this sigma max should be less than, what is sigma max of specimen? SYT in case of ductile material, SUT in case of brittle material. So beta, I will write SYT or SUT. Okay, now if I only write less, will you be able to find a relation? No. In order to find an exact relation, I need to find exactly how much less. So beta, for that we use a certain factor known as factor of safety. So it will become SYT by or SUT by FOS. This is the relation between the stress and the strength. This is the stress, this is the strength. So this is the relation I am getting from maximum normal stress theory, also known as Rankines theory. Is this point clear to everyone? क्या ये point सबको clear है? क्या ये point सबको clear है? Yes, yes, very good, very good, very good, very good, beta, very good, very good. Those of you who are watching me live, please hit the like button once. Savik, Shivendra, Kishan, Dhananjay, Amit, Raju, Sameer, everyone, Neeraj, please hit the like button and don't forget to share the link with your friends. Why the attendance is very less today? I don't know why the attendance is very less today. Please hit the like button and share the link with your friends, and after the lecture ends, don't forget to put your comments. Don't forget to give your feedback in the comments, whether you are liking this session or not, what else you want me to do, what improvement you want, what are the things you like about this session. All those things you put that in comments, okay? Because I am not able to read the live chat, every comment in the live chat I am not able to read. So please put all your feedbacks in the comment section so that I can read them later and I will also reply them. Okay, thank you so much guys. Thank you so much for your valuable feedback. That matters to me. Whatever feedback it is, good or bad, it matters to me. Okay, so please don't forget to put everything you want or you like in the comment section. Okay, now this is the relation we are getting from maximum normal stress theory. Sigma maximum of the machine element should be equal to SYT or SUT divided by FOS. Okay, so from this relation, I can find any one dimension of the machine element. For example, let's say the machine element has a circular cross section, so I can find the diameter. If the machine element has rectangular cross section, so I can find any one, width or height. तो दोनों में से कोई एक चीज जो है वो फिक्स होती है, दूसरी चीज वेरिएबल होती है, so I can find that. Okay, if you are designing a pressure vessel, then you can find the thickness. So in that way you can use this maximum normal stress theory. Okay, now beta, understand, in this theory I am going to assume that the machine element is going to fail due to normal stress. So beta, this theory will be suitable for a material which fails due to normal stress. There are two types of stresses within the material, normal stress and shear stress. Some materials fail due to normal stress, some materials fail due to shear stress. So beta, this theory will be suitable for material which fails due to normal stress, right? And which material fails due to normal stress? Ductile material or brittle material? Brittle material fails due to normal stress. Ductile material fails due to shear stress. So this theory will not be suitable for ductile material. Why? Because here we are not checking the shear stress. यहाँ हम लोग shear stress को check कर रहे हैं क्या? यहाँ हम लोग सिर्फ ये check कर रहे हैं कि sigma max normal stress जो है वो SYT और SUT से कम है कि नहीं, tau max कम है कि नहीं, वो हम लोग check ही नहीं कर रहे हैं. Whether the tau max is within the limits or not, that we are not checking. So beta, this theory is not suitable for ductile material because that fails under shear only. Brittle materials fail under tension, normal stress. So this theory will be suitable for, this theory is suitable for brittle materials as brittle materials fail under tension. Brittle materials जो है वो tension में fail होते हैं. They fail due to tensile stress. So that's why this theory is suitable for brittle material. It is not suitable for ductile material because ductile material fail under shear. And here we are not checking the shear stress. Okay. Now, a very important concept regarding theory of failure, and that is the graphical representation of theories of failure. Graphical representation means this is a mathematical representation, right? Theory of failure का ये एक mathematical equation है, ठीक है? इसी चीज को मैं ग्राफ पे भी प्लॉट कर सकता हूं. I can plot this same thing on a graph. So if I plot this equation on a graph, then what I am going to get, that we need to see. Okay, so we need to find a diagram of maximum normal stress theory, okay, on a graph. So that is graphical representation of theory of failure. Okay, so understand how we draw that graph. Understand how we draw that graph. That graph is also very important to understand. Okay, so in order to draw a graph of theory of failure, first we need to assume that the stress is biaxial. ठीक है, पहले हम लोग क्या assume करेंगे? We are going to assume sigma 3 is 0. Biaxial stress. Biaxial stress मतलब there is no stress in z direction, third direction. There are only stresses in two directions. So we will get sigma 1, we will get sigma 2. Sigma 3 is going to be 0. That is biaxial stress. Okay. So beta, let's draw a graph between sigma 1 and sigma 2. ठीक है, अब हम लोग एक ग्राफ ड्रॉ करने वाले हैं सिग्मा 1 और सिग्मा 2 के बीच में. अज्यूमिंग सिग्मा 3 इज 0. सिग्मा 3 को 0 अज्यूम कर रहे हैं. क्यों 0 अज्यूम कर रहे हैं? बिकॉज बेटा, इफ आई कंसिडर सिग्मा 3, हाउ आई एम गोइंग टू ड्रॉ अ ग्राफ? एक प्लेन में ग्राफ ड्रॉ कर पाओगे क्या? सिग्मा 3 रहेगा तब तो वो 3D बन जाएगा ना. हाउ यू आर गोइंग टू ड्रॉ अ 3-dimensional ग्राफ? सो दैट्स व्हाई बेटा वी नीड अ 2-dimensional ग्राफ ना. वी नीड अ 2-dimensional डायग्राम. So that's why we are assuming sigma 3 is 0. So if sigma 3 is 0, then your sigma max will be equal to what? If sigma 3 is 0, then sigma max will be equal to maximum of sigma 1 or sigma 2, right? Because sigma 3 to 0 hai. Now what is the relation beta? Sigma maximum equal to SYT by SUT divided by FOS. Okay. Now for now, let's assume factor of safety is 1. Why I am assuming factor of safety equal to 1? Because I am drawing the limit of the stresses. How much maximum I can go. तो इसीलिए factor of safety में अभी 1 लेके चल रहा हूं. Okay. So if I take factor of safety 1, then my relation is sigma max equal to SYT or SUT. Right now let's use SYT only. ठीक है, अभी मैं सिर्फ SYT लिखता हूं. बार बार SYT or SUT or SUT, I can't write. Okay, so let's say sigma max equal to SYT. Now understand beta, your sigma max is maximum of sigma 1 or sigma 2. So either your sigma 1 is maximum or your sigma 2 is maximum, right? So let's consider both the cases. Okay, let's consider case 1. What will be case 1? Case 1 क्या होगा? Sigma 1 is greater than sigma 2. This is case 1, right? Now here I am using this absolute sign. Understand the meaning. Sigma 1 is greater than sigma 2 means what? The magnitude of sigma 1 is greater than sigma 2. Okay, let's say sigma 1 is 100. Sorry. Let's say sigma 1 is 100 and sigma 2 is 50. Which one is greater? This is greater, right? Let's say sigma 1 is minus 100 and sigma 2 is 50. Then which one is greater? Again sigma 1 is greater, because negative sign does not mean it is less than 0. Negative sign means it is compressive stress. Positive means tensile, negative means compressive. So it will remain maximum either plus or minus. So here I am writing the magnitude of sigma 1 is greater than sigma 2. So it can be plus sigma 1, it can be minus sigma 1. So beta, it can be plus sigma 1. If it is plus sigma 1, then you will get sigma 1 equal to SYT. And if it is minus sigma 1, then you will get sigma 1 equal to minus SYT. है कि नहीं? अगर प्लस हुआ तो प्लस SYT मिलेगा, माइनस हुआ तो माइनस SYT मिलेगा, right? Now beta, if you draw this here, what you are going to get? What you are going to get? Sigma 1 equal to plus SYT. This is the equation of straight line. Sigma 1 equals to SY plus SYT. This is the equation of a straight line, right? This is the equation of a straight line. Sigma 1 equal to plus SYT. This point will be SYT. And sigma 1 equal to minus SYT. This is also the equation of a straight line. This will be minus SYT. Sigma 1 equal to minus SYT, right? Now beta, what will be case 2? Case 2 क्या होगा? What will be case 2? Case 2 will be sigma 2 is greater than sigma 1. है कि नहीं? Sigma 2 can also be maximum, right? So case 2 will be sigma 2 is greater than sigma 1. Now sigma 2 can also be positive or negative. So one equation I will get sigma 2 equal to SYT, and one equation I will get sigma 2 equal to minus SYT. So beta, I will get two more straight lines. This is sigma 2 equal to SYT. This is sigma 2 equal to minus SYT. This point is plus SYT. This point is minus SYT. So I am getting 4 straight lines. Now these 4 straight lines are giving me a closed diagram. This diagram, a closed region मिल रहा है मेरे को. I am getting a closed region. This region is known as safe region. Understand what do I mean by safe region? Safe region means if your sigma 1 and sigma 2 values are inside this graph, inside this region, your stresses are safe, your machine element is safe. But if it falls outside this region, the machine element is going to fail. So बेटा, अगर मैं सिग्मा 1 और सिग्मा 2 की वैल्यूज को इसके अंदर यहां प्लॉट करता हूं और वो इसके अंदर आ रहा है, मतलब आप सेफ हो, और इसके बाहर जा रहा है मतलब आप फेल हो. Now understand how it works. Okay, let's say you are getting two values. Okay, this value and this value. This is 1, this is 2. तो बेटा अगर दो वैल्यू मिल रही है, 1 और 2 मिल रहा है, तो दोनों सेफ हैं. बट ज्यादा सेफ कौन है? विच वन इज सेफर? 2 point will be safer. Why 2 point will be safer? Because beta it is away from this boundary line. If you are on the boundary line, अगर आप बाउंड्री लाइन के ऊपर हो, मतलब you are just safe. You are just safe. Your stress is equal to SYT. You are just safe. If your stress becomes even slightly more than SYT, you are going to fail. तो बेटा ये जो लाइन है, इस लाइन के ऊपर, on this line, factor of safety is 1. On this line, factor of safety of 3 will be equal to 1. On this line, factor of safety is 1. Inside this line, factor of safety will be greater than 1. Outside this line, factor of safety will be less than 1, means fail. And the distance from this boundary is going to determine the value of factor of safety. जितना इससे दूर रहोगे, factor of safety उतनी ज्यादा रहेगी, means factor of safety of 2 is greater than factor of safety, factor of safety of 1. Do you understand? 2 का factor of safety 1 के factor of safety से ज्यादा है. Why? Because it is at a greater distance from the boundary. 1 is closer to the boundary. जितना boundary के close रहोगे, factor of safety 1 के उतना close रहेगा. जितना बाउंड्री से अंदर आओगे, फैक्टर ऑफ सेफ्टी की वैल्यू उतनी ज्यादा होगी. और अगर आप ओरिजिन पे पहुंच गए, इफ यू आर ऑन द ओरिजिन, मींस योर फैक्टर ऑफ सेफ्टी इज इनफाइनाइट, राइट बेटा? अंडरस्टैंड, ऑन द बाउंड्री मींस फैक्टर ऑफ सेफ्टी क्या है? देखो, ऑन द बाउंड्री मींस सिग्मा मैक्स इज 0, एंड इफ सिग्मा मैक्स इज 0, फैक्टर ऑफ सेफ्टी मींस इंफिनिटी. कोई स्ट्रेस ही नहीं है तो फैक्टर ऑफ सेफ्टी तो सेफ ही सेफ है, इनफाइनाइटली सेफ है, राइट? बट दैट इज नॉट अ प्रैक्टिकल वैल्यू, राइट? Why the stress will be 0? There will be some value of stress, na? So beta, do you understand this safe region, how it works? So beta, for every theory of failure, we are going to get a diagram like this. हर theory of failure के लिए आपको एक ऐसा diagram मिलेगा. Okay, for every theory of failure, we are going to get a diagram like this. So we need to understand how we are going to find this diagram. We are going to understand how this works. For every theory of failure, we need this diagram, and after drawing all these diagram, we are going to make a comparison also. हम theories of failure के बीच में comparison भी करने वाले हैं based on this diagram. Okay, so we need this diagram for the comparison of theories of failure. Okay, if you are thinking why we need this diagram, so we need this diagram in order to compare the theories of failure. Okay, practically also we need to compare the theories of failure, which one is more accurate, which one is more conservative. All those things will be based on this diagram. So beta, in order to do that comparison, we need these diagrams. Okay, so do you understand maximum normal stress theory now? आपको maximum normal stress theory clear है, Rankines theory clear है. According to Rankines theory, the material is going to fail due to sigma max. When sigma max of the material is going to become equal to SYT or SUT by FOS, then beta, is going to be greater than SYT or SUT, then it will fail. So in order to save that, we need this equation. So इस equation से you can find one dimension of the material. Okay, it is suitable for brittle material, and this is the safe region of maximum normal stress theory. So we need these 3 things for every theory of failure. For every theory of failure, we need this diagram, we need this equation, we need this information for which material it is suitable, and we need this diagram. Okay, so we have 5 theories of failure, we need 5 relation, and we need 5 of these diagrams. Okay, so let's move on to the second theory of failure, which is maximum shear stress theory. अब second theory of failure पे चले जाते हैं, maximum shear stress theory, which is also known as Tresca and Guest theory. It is also known as Tresca and Guest theory. Okay, so let's understand what is maximum shear stress theory. Okay, तो नाम से ही clear है, by the name itself it is clear that here we are going to assume that the material is going to fail due to tau maximum, not sigma maximum. It is going to fail due to tau maximum. So understand the statement. A machine element subjected to biaxial or triaxial stress fails when the maximum shear stress at a point in the machine element reaches the value of maximum normal stress. Sorry. यहाँ पे maximum shear stress होना चाहिए, normal stress लिखा गया है. This should be shear stress. Okay, reaches the value of maximum shear stress in a standard specimen of the simple tension test during failure. मतलब कि your machine element is going to fail when the tau maximum of machine element will reach the value of tau maximum of the specimen. जब tau maximum of machine element tau maximum of specimen के बराबर हो जाएगा तब आपका machine element fail हो जाएगा. In last case we assume that the machine element will fail when sigma max of machine element will become equal to sigma max of specimen. Here we are assuming it will fail when tau maximum of machine element will become equal to tau maximum of specimen. So in last case we calculated sigma max in order to find the relation. Here we are going to calculate tau max in order to find the relation. Okay, so let's calculate tau max then. Tau max निकाल लेते हैं. तो बेटा सबसे पहले किसका tau max निकालेंगे? सबसे पहले तो specimen का tau max निकालेंगे. Let's consider the specimen beta. Let's consider the specimen. This is the specimen subjected to uniaxial load. Okay. Now under uniaxial load, when there is only one sigma under uniaxial load, what is tau maximum? You will study this in strength of material. आपने strength of material में पढ़ा था. इस केस में tau max is equal to SYT और SUT by 2. मैं बार बार SYT और SUT नहीं लिखने वाला हूं. I will only write SYT. Okay. If it is a brittle material, replace SYT with SUT. Okay. So tau max equal to SYT by 2 under uniaxial loading. Under uniaxial loading. ठीक है. So this is tau max of specimen. Okay. From where I am getting this relation? If you want to know beta, you need to understand the concept of SOM. Okay. तो जिन लोगों ने पढ़ा हुआ है, जिन लोगों को पता है, वो लोग जानते हैं from where I am getting this relation. Sigma max, tau max in this case is SYT by 2. Okay. Now for machine element. Now the machine element is subjected to tri-axial loading, right? I am assuming that machine element is subjected to tri-axial loading and I have calculated the principal stresses. In every case, we need to first find the principal stress. ठीक है, किसी भी केस में आपको सबसे पहले जो चीज निकालनी है वो है principal stress. Okay, every analysis will be carried out in terms of principal stress. Okay, if you don't know the principal stress, you can't design the machine element. Okay, so beta principal stresses, let's say we have found out sigma 1, sigma 2 and sigma 3. Okay, now what do I need? I need tau max. मेरे को tau max चाहिए. Okay, so how I am going to get tau max in this case? In this case, remember tau maximum is maximum of sigma 1 minus 2 by 2 2 minus 3 by 2 3 minus 1 by 2. Okay, remember this beta, remember this. Okay, you are going to need this. Remember this tau maximum. How we can find tau maximum if we know the principal stress? So tau maximum will be maximum of sigma 1 minus 2 by 2, 2 minus 3 by 2, 3 minus 1 by 2, and I am using again the absolute sign. Why? Because plus minus doesn't matter. यहाँ plus minus matter नहीं करेगा, आपको बस magnitude check करना है. You need to only check the magnitude. Okay, so this is how we get tau maximum. This also I have explained very clearly in strength of material. So I am again and again telling you, you need to know this concept beta, otherwise you will be confused. ये कहाँ से आ रहा है? From where we are getting it? So beta, this is from complex stress in strength of material. So please go and watch that lecture of complex stress, principal stress. You will understand everything. Principal stress के ऊपर आप मेरा lecture देख लो, ये सब समझ में आ जाएगा. Okay. Now we have tau maximum of specimen, we have tau maximum of machine element. So beta, according to this theory, the machine element is going to fail when this tau max will become equal to this tau max. Now I don't want failure. I want to save the machine element from failure. So to avoid failure, what will be the equation, beta? Tau maximum of machine element should be less than tau maximum of the specimen. मशीन एलिमेंट का टाउ मैक्सिमम स्पेसिमेन के टाउ मैक्सिमम से कम होना चाहिए. दिस विल बी द रिलेशन टू अवॉइड द फेलियर. नाउ व्हाट इज टाउ मैक्सिमम ऑफ मशीन एलिमेंट? दैट आई डोंट नो राइट नाउ. It can be this, it can be this, it can be this. Right now I don't know, so I am not going to write it. I will simply write it tau max. Okay, in exam you will get the values of sigma 1 2 3, so you can find out which one is tau max. Right now I don't know, so right now I am simply writing tau max. Okay, but I know the tau max of specimen. Specimen का tau max कितना है? SYT by 2. So it will be less than, it should be less than SYT by 2. But how much less? वो कौन बताएगा? Who will tell me how much less? Factor of safety will tell me how much less. So beta tau max should be equal to SYT by 2 FOS, right? This will be the relation between tau max and SYT, stress and strength. Is this clear to everyone? क्या ये चीज सबको clear है? Is this clear to everyone? Yes, Aniket, Naveen, Prasad, Ashutosh. Yes, Ajay, Jai Kishan, Raju, Rashid, Mehboob, Sameer, Naveen. Everyone is clear about this? Yes, crystal clear, diamond clear. Very good, beta, very good. Thank you so much. Thank you so much. This is like a compliment for me. This is like a compliment for me. Yes, Prasad, if you are asking me why brittle material fail under tension and ductile material fail under shear, you need to understand the concept of material science. Okay. In material science, you will understand, you need to know what is inside the material, what is happening inside the material. So from the concept of SOM and machine design, I can't explain you. We need the concept of material science, grain boundaries, slip, dislocation movement, all that you need to understand, and that is in material science. Okay, so material science mein you will understand why brittle material fail under tension and ductile material fail under shear. Okay, वो चीज आपको वहीं से समझ में आएगी, नहीं तो नहीं समझ में आएगी. Okay, all right, all right. So beta, now we have a relation between the stress and strength. What else do I need? I need the information that for which material it is safe, for which material it is suitable. So beta, here I am assuming that the machine element fails due to shear. तो किस मटेरियल के लिए ये अच्छा होगा? For which material it is going to be suitable? It is going to be suitable for ductile material. So this theory is suitable for ductile materials as ductile materials fail अंडर shear. ठीक है, ये डक्टाइल मटेरियल के लिए सेफ है क्योंकि डक्टाइल मटेरियल shear में फेल होते हैं, एंड हियर आई एम अज्यूमिंग दैट द मटेरियल इज फेलिंग ड्यू टू shear. So this is not suitable for brittle. Brittle materials fail due to tension, sigma. Ductile material fails due to shear, tau. So is this point clear to you? This is very important from theory point of view. Theory में आपसे पूछा जाएगा बेटा, आपको एग्जाम में भी पूछा जाएगा, आपको इंटरव्यूज में भी पूछा जाएगा. So beta, you need to understand all these points about theories of failure. It is very important from interview point of view also. Interview में भी बहुत सारे question आपको theories of failure पे मिलेंगे. So beta, this is a very important topic from interview point of view also. Okay? और यहाँ पे number of likes are less. Why the number of likes are so less? Please hit the like button. Please hit the like button. And I want all of you to share this video with all your friends. Why the number of attendance, why the number of live people is very less? Yesterday also it was this much, today also it is this much. Why the number of people attending live sessions are day by day decreasing? We want this number to increase, not decrease. So it is your responsibility. Share the link with your friends, beta. We are giving our 100%. So beta, it is your responsibility too that the numbers should grow. हम अपना 100% दे रहे हैं, so I need your support, I need your cooperation. Okay, we are like a family. Unacademy GATE, ESE, PI is a family, is a big family. All you subscribers, all you followers are the members of this family. So beta, it is our duty that the number of people attending these classes must increase day by day, not decrease. ठीक है? तो बेटा थोड़ा सपोर्ट करो यार, शेयर करो लिंक सबके साथ. ओके, शेयरिंग इज केयरिंग, राइट? तो आप एक अच्छा काम कर रहे हो नॉलेज शेयर करके. सो बी अ पार्ट ऑफ दिस. ओके, ऑल राइट. सो बेटा नाउ वी नीड टू ड्रॉ द ग्राफ. ग्राफिकल रिप्रेजेंटेशन जरूरी है. सो बेटा लेट्स ड्रॉ द ग्राफ. अब इसका ग्राफ जो है वो अच्छे से बनाते हैं, थोड़ा सा बड़ा बनाते हैं. ओके, पिछली बार ज्यादा कंजूसी हो गई थी. सो लेट्स मेक अ बिग ग्राफ दिस टाइम. ओके, नाउ बेटा अकॉर्डिंग टू मैक्सिमम shear stress theory, the material is going to fail when tau max will become equal to SYT by 2 FOS. Again, I am taking FOS equal to 1. Why? Because beta I am drawing the boundary of the region ना, और boundary पे FOS क्या होता है? 1. Okay. Now, what will be your tau max? Assuming sigma 3 equal to 0. Assuming sigma 3 equal to 0, tau max will be equal to maximum of sigma 1 minus sigma 2 by 2. ठीक है? Second term will become sigma 2 by 2 because sigma 3 is 0, and third term will become sigma 1 by 2 because sigma 3 is 0. Okay, तो sigma 3 0 रख देंगे तो ये second term हो जाएगा sigma 2 by 2, third term sigma 1 by 2. So out of these three, anyone can be maximum, right? Anyone can be maximum. Now understand beta, understand different permutation and combination. Let's say sigma 1 is 200, sigma 2 is 100. So beta both are positive. So what will be sigma 1 minus 2 by 2? 200 minus 100. 100 by 2 means 50. Sigma 2 by 2, 50. Sigma 1 by 2, 100. So this one will be maximum, right? Let's say sigma 1 is 300, sigma 2 is 400. So beta this one will be how much? Sigma 1 minus 2 by 2. This one will again be 50. Sigma 1 by 2 by 2, 200, 150. So this one will be maximum. Ab beta, let's assume sigma 1 is minus 100, sigma 2 is 40. अब मान लो assume कर लेते हैं sigma 1 minus 100 है, sigma 2 40 है. So minus 100 minus 40 by 2 ये हो जाएगा आपका 70. Sigma 2 by 2 20, sigma 1 by 2 50. प्लस माइनस छोड़ दो, यहाँ पे माइनस साइन कंसिडर करने की जरूरत नहीं है. माइनस 70 माइनस 50 यू डोंट हैव टू राइट. सो बेटा नाउ विच वन इज मैक्सिमम? दिस वन इज मैक्सिमम. तो बेटा एक चीज ध्यान दो, अंडरस्टैंड दिस वन थिंग. इफ सिग्मा 1 and 2 both are positive, then either sigma 1 will be maximum or sigma 2 will be maximum. So either this will be maximum or this will be maximum. But if sigma 1 and 2 are opposite, one is tensile, one is compressive, one is positive, one is negative, then beta this one will be maximum, right? तो ये चीज आपको क्लियर हो रही है? Sigma 1 and 2, if both are positive or both are negative, then out of these two you are going to get any one maximum. But if both are opposite, one is tensile, one is compressive, then this one will be maximum. Why? Because this sigma 1 and sigma 2 will add, right? If one is positive, one is negative, then this will be added, not subtracted. So this one will become maximum. So beta now in a different quadrants, I will get different relation. अलग अलग quadrant में मेरे को अलग अलग relation मिलेगा. Quadrant means, understand beta, in this first quadrant both are positive. In second quadrant one is positive, one is negative. In third quadrant both are negative. In fourth quadrant one is positive, one is negative. So beta in every quadrant I am going to get different result, right? So beta let's understand. let's understand in first and third quadrant what will happen. Okay, first और third quadrant में क्या होगा. Okay, so case one, sigma 1 is positive. फर्स्ट क्वाड्रेंट ले लेता हूं मैं, यहां पे फर्स्ट क्वाड्रेंट ले लेता हूं. ओके, फर्स्ट क्वाड्रेंट. ओके, so in first quadrant either sigma 1 will be maximum or sigma 2 will be maximum. Okay, so if sigma 1 is greater than sigma 2, then what will be the relation? Sigma 1 will be, sigma tau max will be sigma 1 by 2, है ना. tau max क्या हो जाएगा? sigma 1 by 2. so this will become sigma 1 by 2 equal to syt by 2. so I will get sigma 1 equal to syt, है ना. अगर sigma 1 बड़ा हुआ sigma 2 से, फर्स्ट क्वाड्रेंट में this will never be maximum because both are positive, so this will never be maximum. so either this will be maximum or this will be maximum. so beta either sigma 1 will be syt or sigma 2 will be greater than sigma 1, so sigma 2 will be equal to syt. okay, तो फर्स्ट क्वाड्रेंट में you are going to get this, है ना. जस्ट लाइक मैक्सिमम नॉर्मल स्ट्रेस थ्योरी, मैक्सिमम नॉर्मल स्ट्रेस थ्योरी वाला ही रिलेशन मिलेगा यहां पे. मैक्सिमम नॉर्मल स्ट्रेस थ्योरी में भी या तो सिग्मा 1 बड़ा होता था सिग्मा 2 से, या तो सिग्मा 2 बड़ा होता था सिग्मा 1 से. सो वी गेट दिस रिलेशन एंड दिस रिलेशन. तो बेटा वही दो लाइन यहां भी मिल रही है. इन थर्ड क्वाड्रेंट ऑल्सो आई एम गोइंग टू गेट द सेम थिंग बट माइनस syt, है ना. because here both are negative, here both are positive, here both are negative. okay, now beta let's consider second quadrant. okay, अब second quadrant में चलते हैं. second quadrant means one is positive, one is negative. so your tau max will be sigma 1 minus 2 by 2, right. तो अब आपको रिलेशन क्या मिलेगा? सिग्मा 1 माइनस 2 बाई 2 इक्वल टू syt बाई 2, और ये माइनस में रहेगा बिकॉज सिग्मा 1 विल बी नेगेटिव. तो सिग्मा 1 को नेगेटिव रखूंगा तो माइनस माइनस ये माइनस आएगा. ओके, सो सिग्मा 1 माइनस सिग्मा 2 इक्वल टू माइनस syt, राइट. नाउ दिस इज ऑल्सो द इक्वेशन ऑफ अ स्ट्रेट लाइन. व्हाई दिस इज नेगेटिव? अंडरस्टैंड, सिग्मा 1 इन सेकंड क्वाड्रेंट सिग्मा 1 इज नेगेटिव ना, तो माइनस सिग्मा 1 माइनस सिग्मा 2 you will get negative value, so that's why minus syt. okay, so beta sigma 1 minus sigma 2 equal to minus syt. this is also the straight line equation. if you put sigma 2 equal to 0, sigma 1 will be minus syt, and if you put sigma 1 equal to 0, sigma 2 equal to plus syt. so beta I will get this straight line. this is sigma 1 minus sigma 2 equal to minus syt, and just like that in fourth quadrant also I will get this straight line. this will be sigma 1 minus sigma 2 equal to plus syt. ठीक है. so beta in first and third quadrant you are going to get the same region as maximum normal stress theory, but in second and fourth you are going to get a different region. so this is the safe region of maximum shear stress theory. अब बेटा after drawing all the theories of failure, all the graphs of theories of failure, I am going to give you a comparative analysis. I am going to compare the safe regions after we draw all the 5 theories of failure. right now I am not going to compare them. अभी मैं compare नहीं करूंगा, but last में मैं compare करूंगा जब पांचों theory of failure cover कर लेंगे. okay, so this is the diagram, this is the graph of maximum shear stress theory. so we have seen the graph of maximum normal stress theory, this one, and this is the graph of maximum shear stress theory. okay, now beta we have exceeded our time. so beta tomorrow I am going to continue and I am going to cover the rest of the 3 theories of failure. today we only saw maximum normal stress theory. आज हम लोगों ने maximum normal stress theory cover की and maximum shear stress theory cover की. tomorrow I am going to cover maximum strain energy theory, distortion energy theory, and normal strain theory. okay, so beta today we saw what is design against loading. okay, design against loading means the load is given and you are calculating the dimension of the body. then we saw why do we need theories of failure? So under biaxial and triaxial loading, we have multiple stresses. So in order to relate these multiple stresses with strength of material, we need theories of failure. Then we saw that there are 5 theories of failure. One by one, we are covering each theory of failure. Each theory of failure will give you a relation between the stress and strength. And for each theory of failure, we are going to get this graph also. Okay. So today we covered 2 theories of failure, maximum normal stress theory and maximum shear stress theory. Tomorrow we are going to cover maximum strain energy theory, maximum distortion energy theory and maximum normal strain theory. And then we are going to solve a few numericals also. Okay. So बेटा tomorrow we are going to have a DPP session also. कल अपन एक DPP session भी कर लेंगे, ठीक है? तो आज हम लोगों ने theory of failure का concept देखा और 2 theory of failure भी cover की. Okay? Don't forget to hit the like button and don't forget to share this video with your friends. And a very important information, beta, a very important information, the prices are going to hike. So don't forget to take Unacademy Plus subscription as soon as possible. Unacademy Plus subscription prices are going to hike from October. So if you are thinking of getting Unacademy Plus subscription, then beta within these 1-2 days, you take the subscription. Even if you are thinking of preparing for GATE 22 or GATE 23 and you are thinking of taking the subscription in January or February, beta it is going to cost you more. So take the subscription now. 1 year subscription in the future will be more costly than 2-year subscription right now. अगले साल 1 year subscription लेने से अच्छा इस साल 2-year subscription ले लो, वो ज्यादा सस्ता पड़ेगा आपको, ठीक है? क्योंकि आगे जाके प्राइसेस बढ़ने वाले हैं. So बेटा take the subscription using this code APPROVED10. 1 year subscription, after applying this code, you are going to get 10% off. So 1 year subscription will only cost you 22,500 and 2-year subscription will only cost you 27,000 rupees. Okay. And beta, if you compare this cost with any other academy, offline and online, beta, you will not get better result than, you will not get a better deal than this. This quality of education at this cost, nobody can provide you. And what are the advantages of Unacademy Plus subscription, beta? Here you get multiple batches. Okay, I have just shown you 4 of my batches. Apart from these 4 batches, I also am part of other batches. For example, just now, this month only, we have launched All-Star batch, where only the top educators of Unacademy are providing you a batch course of GATE 2021. Okay, only the top educators of Unacademy are there in that batch. Okay, so I am a part of that batch also. So only me, I am a part of 6-7 batches, and apart from me, there are other educators, other batches. So you have an advantage of multiple batches. You can join multiple batches at a time. Okay, you can join a GATE batch, you can join an ESE batch. There will be crash courses for other exams also. So this facility will not be there in any other academy. In any other academy, there will be a separate batch for GATE. You have to take subscription for GATE. There will be a separate batch for DRDO. There will be a separate batch for ISRO. There will be a separate batch for SSC. There will be a separate batch for ESE. But here, beta, you have one subscription, multiple batches. एक ही subscription और सारे batches आप cover कर सकते हो. So take the subscription now, beta, using the code APPROVED10. Why this code is important? First of all, you are going to get 10% off. Okay. Second of all, the moment you use this, you are going to be connected to me. I am going to be your mentor. So I will guide you throughout the procedure. I will guide you throughout your preparation. I will provide you all the things that you need additional to the lectures. Lecture के अलावा जो भी चीजें चाहिए, you need daily guidance. You need to know which subjects to follow now, which subjects to follow later. You need to know how to take full advantage of online classes. You need daily motivation. You need a proper guidance in a particular, in a path. आपको एक right path में ले जाने वाला कोई चाहिए. So beta, I will give you that guidance. I will be your personal mentor if you use this code APPROVED10. So take Unacademy Plus subscription using this code. You can pay this fee in EMI also. There are no cost EMI available. No cost means you don't have to pay anything extra. Whatever your fee is divided by number of months, you will have to pay only that much. Okay. For example, if you are taking 1 year EMI for 1 year subscription, 1 year subscription is 22,500 and 1 year EMI means 22,500 divided by 12, 1875 rupees per month or 60 rupees per day. But don't forget to use this code, your favorite referral code approved10. Take the subscription now before the prices hike. Thank you so much. I will meet you tomorrow with some more amazing content. Thank you so much. Hit the like button before leaving. Thank you so much. Thank you so much.